Hi, I'm Lucy Bellamy. I'm interested in the Chem Peer Mentor program, especially for Chem 102, because Chem 102 was my first chemistry course here at UNC, and I didn't come in planning to be a chem major, but I really learned to love the material in that class. So that's kind of the foundation of my love for chemistry. I also really relied on the peer mentors in that class as it was my first class at UNC. I really took their advice. I appreciated their recitations, and I even got in touch with one of my peer mentors from that class to talk about applying for this program. Earlier this semester, I've also been helping some other Chem 102 students prepare for their exams, and I found that really rewarding to help other students find an understanding and a greater appreciation for introductory chem, since it is the basis for all of the chems that we do in the future. So I really just want to continue that teaching component and help other students and also gain more of a mastery of this introductory chemistry. Since I am a chem major, I think it would be good to just really get that under my belt so that I can continue being successful in the future. The problem that I am working today is what is the pH of a 1 molar solution of nitrous acid, given that the Ka value is 4.5 times 10 to the negative 4. So the first step that we're going to do is write out the acid-base reaction for nitrous acid and water. And then just from memorization of those strong acids, you'll know that nitrous acid is actually a weak acid, so you do that double-headed arrow to give you the hydronium ion and the nitrite ion. You know that nitrous acid is the acid in this equation due to pKa's. This pKa value is much smaller than water. Since nitrous acid is a weak acid, you cannot use this given concentration in the question to find your pH value. Instead, you'll have to use the Ka equation, which uses the concentration of the products over the concentration of the reactants. However, you do not include water in this denominator since it is a liquid and you're only trying to include aqueous products and reactants. So from there, you know that in a weak acid dissociation, the hydronium ion and the resulting conjugate base will be of fairly equal concentration. So you can go ahead and denote them both X and take a little shortcut and give yourself X squared over that concentration of nitrous acid, which is 1 molar. Then you do a little plug and chug, find that Ka value, plug it in, 4.5 times 10 to the negative 4 equals X squared over 1. Then you solve for that X value to get the hydronium concentration, which will then lead you to find the pH. So X equals hydronium ion, which will be the square root of that Ka value, 4.5 times 10 to the negative 4. From that, you find the answer of 0.0212. Then you use your pH equation, which relates the hydronium concentration to pH. pH equals negative log of H3O plus or H plus, which gives you the negative log of 0.0212. Finally, once you solve that, you get the final pH value of 1.67.